Okay, now geolocation. So let's understand this. Geolocation is the identification of real-world geographic location of objects such as source of radar, mobile, or whatever. It is a technique in which users from different parts of the world get into different servers using the magic on the internet. So what is this magic? The placement of DNS servers across different locations using any cast. Now the return address is according to the subnet from where the request came. Okay, so let's understand this stuff as such. It's pretty interesting. Now, yesterday, I don't know whether you recollect, I used a word called CDN, Content Directory Networks. Okay, so what are these CDNs? And I told you, imagine I want to host my application. I want to host my website, okay? So this particular website is hosted in, say, US, which was earlier, this is what we used to all do, because most of the servers were located there. This website is hosted in US. Now, any user who's going to sit in India will have to travel all the way to US to get the request, right? To get that query, to get that particular website, we need to go right up to the US and pull the request down. Now, imagine a situation, if I had kept a copy of this website in India and the user located in India, when you're querying, we will tell him, you please don't go to US server, we have a copy of it kept in India. Okay, now this is what is called as geolocation based DNS resolution using this process called Anycast. Okay, so Anycast is a networking technique where similar IP address is advertised from multiple locations. When the network decides which location to route a user request to based on routing protocol cost, that is the distance, okay, and possibly the health of the server. Now imagine the server is located in India, but the Anycast request, which is actually configured not in any of your DNS, it's a part of your router, keeps a track saying that there is a problem with this server, so you please don't go to the India server, go back to your US server. So it does that in two ways. One is through your cost, the distance, and the other one is through your health checks. Okay, so what does Anycast do? Anycast, using your subnet, your IP address range, where you come from, will redirect you to the closest server for browser. Okay, so when you do google.com, it will not go to the Google server in US. It will come to the closest area of your Google. Most likely that could be either Singapore or Hong Kong, wherever the Google data centers are. So this is called Anycast way of handling, and though this is not configured in any DNS, but it is kept as a part of your router configuration, and we can't do much about it. It's a prerogative of the network engineers who handle this Anycast, but we understand that there is a concept called Anycast. Okay, so this is how that the entire geolocation things are handled. But of course, this is too much of a complexity in terms of even I am not so very clear on how the entire routing handles, because it's part of the network engineering who handles this whole stuff. But in essence, this is what it's all about. Okay, so that much on your DNS. So now we get into the other server, which is your web, the other of the infrastructure component, which is your web server. And I'm sure you already understand this, but let's go through this stuff again. So web server, everybody knows, is a server which serves requests using HTTP protocol. It can be the entire server or the software running on it. Okay, so the primary function of web server is to store and process and deliver web pages. Okay, we all know there is some features like virtual hosting, large file support, bandwidth throttling, server-side scripting. I mean, are all aware of these concepts, or how is it? Okay, so what is so let me probably explain them. So what is virtual hosting? Now, virtual hosting means within a single web server, I can host multiple domains. Right? Within a single server, we can host multiple domains. So that means I will have a single Apache server running, but that would be hosting multiple domains. One may be a yahoo.com, or it could be a google.com, and it could be an msn.com. So that is virtual hosting. And all the service providers actually do service hosting because otherwise we may have to have multiple instances of web servers and multiple network cards and stuff. And in virtual hosting, I could do a virtual hosting with a single IP address pointing to multiple domain servers. I could do that. Okay, and which is a little confusing the way it works. We could also have multiple IP addresses pointing to sorry, not multiple, I say, or one-to-one mapping of your IP address and your domain name. So each domain will have its individual IP address. So that way also we can do. Okay. Then this large file supporting. Okay. So today your web servers are not just hosting your web pages. It can kind of today hold, you know that, right? Yeah, I can put a complete ISO image of my server in the web server and then source it from that. So you could do that. Then bandwidth throttling. So what is bandwidth throttling? We could control the kind of limit, or when I say the limit, the speed through which a service is being done. We could do that actually. I mean, of course, we're not going to use that for a web server for that, but there is a feature. There are other ways to get that done. And server-side scripting. So what is server-side scripting? When I say server-side scripting, that means integrating your Apache to host application designed with different programming languages. So like PHP, like Python, like Ruby, etc. Okay, so this is what you mean by server-side scripting as such. Okay. Any questions with this? Okay, so what is this HTTP protocol? Okay, so HTTP stands for Hypertext Protocol. It is used for, it is the underlying protocol used by World Wide Web. It defines how messages are modified and transferred, what action web servers and browser should take in response to different command, and your entry, you enter a URL in the browser and HTTP command is sent across your web server to fetch and transmit the web pages. Okay, so let's see these, what does this protocol means. So this particular protocol has a lot of commands. Okay, like I'm sure you might have heard of this, your get command, your post command, delete. There are various kind of such commands. So what you do is, you know, when you say www dot some google.com or whatever it is, in the back end you are actually sending a protocol like this. Okay, you're sending a protocol like this. What you're saying is, get me that file. Get me that file. The file name is it's in this path, and yeah, and its name is file.html, and please use protocol 1.1. This is what happens when you type, say, www.google.com or not. Okay, so get is to get all your web pages. So this way, when I'm browsing, it's actually we are using a lot of these get, but it can also be used for other purpose. Now, imagine a situation where you're going to, say, doing a registration, say booking a ticket or whatever. In this case, what we're trying to do is we are sending some data which we have typed in our web page to the web server, right? And what happens there is this web server in turn captures all this data, and then it calls the respective language in which it is processed, okay, and it does the processing. It could be a submit or a retrieval or whatever that may be, and it comes back into your page. So for that we use this protocol called okay, I think it's not mentioned here. We use a protocol called POST. So like that, HTTP has multiple protocols: get, POST, what those things mean. Okay, so are you getting this? Any questions here? Okay, so this is how a HTTP program or a web server actually works. Then, if you have noticed, this HTTP server has a lot of these. You get this, numbers like 200 or 400, which is pretty much common. Okay, and sometimes you hear this fine. So if it's errors on your on internet are quite frustrating, especially when you do not know the difference between everything. So these errors are called HTTP status codes. Okay, are response codes given by the web server, and these help in identify the cause of the problem. So what are these? It's important to know these codes, and it helps you to debug this. These information codes, 100 means it is continue. That means it's just an informational code. If it's 200, that means the web page has been downloaded and there's no problem. If it's 300, that means that URL does not exist and it's redirecting you to another place. If it's 400, that means that URL does not exist. And if it is 500, that means I think if you've been developing any applications, you would have noticed when you notice that the web so when you are kind of doing a registration, you have to call some programming language. If the programming language in a simple case may not have an execute permission, then you also get such errors like this. Okay, so this is where these errors are, and they are these are the different types, and that's how you know your status of your web as such. Okay, now there are actually so many web servers that are in the market, so many of them. The most popular is Apache, and today the second most popular web server is what is called as Nginx. Okay, I'm sure you might have heard of this. It's becoming the second most popular web server in the market, okay, followed by your Microsoft's IIS, Internet Information Server, and a host of other servers that are there. But Apache 10 continues to be the most important and the most powerful. Okay, the most important and the most powerful, and Nginx kind of coming up to be the next most important. Now, the configuration of your Apache. Now, that's a very simple thing. You have to install your web server. Okay, that is through either it could be, if it's CentOS, it's going to be HTTP installation. Then it just has a single configuration file. Okay, so it just has single configuration file, which is called your http.conf, and the directory where all your objects are kept. When I say object, this is your images, your HTML files, or your or any other files that you want to serve through the web are kept in this particular path. Okay, so this is how this is configured as it. And then of course we're going to do the labs of all of these things. Any questions? Okay. Then once you have configured it, there is you start your service. The service is called HTTPD. Okay, and if you make some changes in your HTTP conifer, and if you want to immediately take effect, we do this command called reload. Okay, so it's the example like adding a new domain into your configuration file. So we add this and then we reload the whole stuff. Okay. Okay, so if you look at your http.conf, you will have a lot of these configuration setups, and some of all are all these, like root server. This specifies where your documents are going to be located, and in this case, your var whtml is your root server. Okay. Then keep alive. Whether server allows one or more requests per connection. Okay, I'm not sure how many of you all know this. When I do a browsing through any of the browser, it is not a single connection actually. There can be multiple connections. So what happens in multiple connections means that I'll be opening two different sockets to connect to this particular server, which actually just helps in improving your speed and things like that. Now, keep alive is another situation where I do not want to creating socket every time I try to connect to a web server, and anytime I also connect to a web server, I want to use that existing connection to actually send the request. Else what happens is, if I don't say keep alive, I'll be keep opening up and be sending my connections to new socket every time I want to process something. So this helps in kind of doing a single pipeline is always opened up to do it multiplexes. Basically, it multiplexes. Start servers sets how many server process you have to start. So when an Apache starts, there is a server which starts up. Okay, so what is this is so this server handles each of your client requests. But if there is only one server, and then I can only start, then only one guy can actually connect to it. So, but what he does is he starts child process. So max requests, the total number of requests each child server process serves before the child dies. Okay, so that's your child process. And max client sets the total number of server process that can run at one time. So what that means is when somebody says that I'm able to process 1,000 requests per second, it means that the server is designed to handle 1,000 clients simultaneously, and that's what the max time. Okay, and then you have the min spare and max spare. If number of servers waiting for a request is less than min server, it creates some, and if the number of servers waiting for request is more than max, it kills some. So what this does is, see, I'll tell you why Nginx has become so popular is every time I have to connect to a server, I will have to spawn a socket. Okay, I will have to spawn a socket. The spawning of the socket is a very expensive process within your server, and it takes definitely some milliseconds for this to happen. Now, if there are thousands of them, it's very difficult for your server to handle, and it starts going slow. Okay, so that is why sometimes you instead of waiting for some client to come, you keep some minimum servers ready, and if you feel that it is actually going, it's not going going down, I actually kill this. So that is what this min and max servers are. Okay, any questions? Okay, so yeah, as I said, it's the most widely used. It's an open source. Uh, uh, Rather, every flavor of Unix actually has its own. So you might have heard sometimes there's an IBM HTTP server, Oracle HTTP server. Now they are all Apache servers rebranded by these organizations. Basically, they're using just Apache as the server to do the services. Okay, as a part of so the whole idea of having a web server is definitely to do some kind of content serving. Now, for this content serving to happen, we have to integrate this toward DNS. Otherwise, we'll have a problem, right? That's what we have seen. Now, how the web server itself is placed in an organization depends on how do you design a firewall. And as always, as I said, firewall has three legs: your public side, your private side, and what is called as the DMZ, or the demilitarized zone kind of a site. Okay, so all your web servers or any server that needs to be internet facing are kept in your public side, in your DMZ side, and all the DNSs and all the DNS entries which needs to talk to these servers are kept in the public DNS, not in the internal DNS. Okay, so that you need to understand. If you keep this in the internal DNS, then the public who is going to come will never find this server. So you understand, I'm sure you understand why it has to be kept in the internal. Now you also get a confusion here. You have an Apache server which is serving the internet, right? But what about the internal users? So what they do is, now to handle such a kind of a scenario, internal DNS will have to create its own entry to actually point to this part. So normally they don't do a forwarding. They will create another pointer to this to the web server so that it could handle both. When you are in the DMZ zone, you could move from internal to DMZ, but not to the external side, and the external could come from outside to the DMZ. So DMZ is like a quarantine. It's a bit of a quarantine. It's a controlled area where people from both places could come and interact. Yeah, and you know it, and this is to keep all other unwanted users away. That's the whole idea of this particular setup, right? Apache can run in two modes: pre-forked and worker multiprocessor mode. Pre-fork mode creates one thread per process, each of which handles one user request. In pre-fork mode, process handles one connection only. This process is thread safe. Whereas in worker mode, creates new process too, but each has more than one thread, and each of which handles one request per user. In worker mode, process handles more than one connection. Okay, see, this is an architectural design of your application. Okay, so there are two ways for your application to be designed. Okay, now let's take a telephone example, try to answer this particular solution. Okay, now if I'm making an individual call, I can't talk to anybody, neither the person on the other side can talk to anybody, isn't it? It's just a one-to-one connection, and we can't just get out of that loop, right? But imagine if you're doing a conference. We have simultaneously many people handling, many people coming in and talking, and it's a completely two-way, right? It's a two-way talking, but it's a conference. There are multiple guys who are getting connected there. So Apache server has also been designed in there. When I say pre-forked, it is one-to-one. And when I say multi-worker mode, that means one socket can handle multiple connections. Okay, so what is the advantage? See, there was this challenge called C10K, C10K. Now, this particular challenge, I probably do not know who might have, who actually started off. Of course, you can see it on the net. Is the challenge was, can I use my existing web server, and can I have 10,000 simultaneous connections? I'm talking of not the present servers, the earlier servers. I think these were the times when you had that 1 gig processor. Can it handle 10,000 connections? Apache server could not, because to handle such a kind of a connection, you need to have very fast CPUs and equally good amount of memory. Okay, only then you could handle. Now, so they realized that in a pre-forked environment, this would not happen. So they designed this architecture of worker mode way of processing, in which if I have 10,000 connections, right, I would not open 10,000 sockets. I will, in your worker mode, I won't open 10,000. I will just open up some 10-20 of them, and these 10-20 can then handle actually 10,000 people. So that's the architectural difference. Just like how your the analogy is basically the way group chats and group conference calls work. That is the whole, where there is a way of slicing and weighting and dicing. I mean, a lot of things in terms of how that multiplexing happens there. It's a time division there. Each, though it appears that everybody is together, there is definitely a serial way of connection which is happening, but we do, because of the speed of the process, we are not able to feel that. You feel all of them are happening together simultaneously. Okay. Are you getting this? Any questions that are arising in your mind? Okay. So the limiting factor, as we all know, has been the memory, which has always been a problem for all the internet-facing web servers, right? And the potential to deadlock threads that are contending for the same CPU and memory. So if a thread is stopped, the user waits for the web page to appear until the browser makes it free, so it can send back the page. If a thread is deadlocked, it does not know how to restart, thus remaining stuck. Okay, so when does a deadlock happen? Deadlocks happen when there are too many threads. If there are too many threads, I mean, we know, right? When there are too many people, there is a general chaos if they are trying to seek an attention of some particular stuff, right? So the same thing happens within the CPU itself, and we don't know how the deadlocks happen, right? Because everybody are given a certain amount of time to process, and during this time, if that particular web page is he is not able to get, then there may be other guys who are trying to vie for that CPU time, and during this process, certain threads can just get hung, and it gets hung, and then nobody is able to process. So that's why these deadlocks kind of happen. Yeah, it could be any reason. We really don't know how and what is the reason behind a lot of these deadlocks.